Today we're going to evaluate definite integrals. Remember the evaluation theorem from the previous lesson. This is an indefinite, actually we're evaluating some indefinite integrals today too. So we've got the indefinite integral. Notice I don't have the points of integration. So this is just the integral of f of x dx. So we have to treat this slightly differently because we can't actually plug numbers in and get a number answer. In fact, we won't get number answers, we'll get functions out of this, or a family of functions. So we've done a little bit of this in class. We're just going to formalize this a tiny bit here. So we have some table of indefinite integrals. You're going to find these on page 369 in your book. There's a lot of them. You may not want to write them down right now. You might want to write them down maybe as you need them, or when you have a little more time than you do now. If you got time now, go ahead and get these into your notes. Otherwise, they're on page 369. We've been dealing with this one. If we have a power, we add 1 to the power and then divide by the new power, and then we need to slap the plus c on there because we don't know what the constant would be. This is for n not equal to -1. The integral of 1 over x is in the natural log of the absolute value of x plus c. The integral of e to the x is e to the x plus c. The integral of a to the x is a to the x over the natural log of a plus c. The integral of sine is negative cosine. The integral of cosine is sine. The integral of secant squared is tangent. The integral of cosecant squared is negative cotangent. The integral of secant x, tangent x is secant x. Don't forget your plus c's. And we have a couple of ones down here that show up just often enough that we need to know them. When we see 1 over x squared plus 1, that's tangent inverse of x. And when we see 1 over root 1 minus x squared, that's sine inverse of x. Again, these are all on page 369. Kind of make a note of this one. This is going to show up later today in this lesson. So we're going to find the general indefinite integral. It's not a definite integral. A definite integral evaluates to a number, so we would have points of integration. Indefinite means we can't really get down to a number. There's going to be that plus c, that plus constant on the end of some big function. So we just integrate each term individually and then make sure we add the constant. Again, we're going to integrate each term individually, but when we run into this one, if we take the 3 and say this is 3 times 1 over x squared plus 1, there's that tangent inverse term showing up in here. So that'll be 3 times tangent inverse. Remember, 1 over x squared plus 1, the integral of that was tangent inverse of x, so that's where that shows up. We can actually evaluate this one, though, because we do have points of integration. So let's plug in the 2 and minus plugging in the 1, and we get approximately negative 0.67855. That's our target for today. I'll see you in class.